This is lesson 8 in Algebra 1. It has to do with area. And area is one of those interesting things because when it's a square or a circle or something like that, it's kind of easy to find the area. But when you have something that looks like this, that's a little more difficult to find the area. In fact, use calculus, which is a little bit down the road for most of you. You'll take this course and then intermediate algebra and algebra 2 and college algebra and college trig, and then you'll get into calculus, which is figuring out the area of weird shaped figures like that. So area is just how much space something takes up, how much carpet it's going to take to fill a room, how much grass it's going to take to fill a yard, how much area or how much room a house is going to take when it sits on the dirt. So what we've got here is areas of rectangles and squares. So we've got an area of a rectangle. Rectangle is two opposite sides are parallel. Those two sides are parallel, so they're the same length. And the area of a rectangle is length times width. And again, this is a multiplication symbol. Just a little dot there. I use that instead of an X most of the time. The area of a square is also length times width, but the difference is in the area of a square, the sides, well, let's call them length, and the width are the same number. So we'll call them sides. So let's, instead of length and width, let's just say that side and that side. And by calling them both sides with an S, we're saying they're the same length since we're using the same letter. So this times this, S times S is S squared. So the area of a square is S squared. The area of a rectangle is length times width, or they'll do it something like this, lowercase letters for length times width. All right, so when you're getting a figure that isn't necessarily a nice little rectangle, such as the example for 8.1, we get something like this. This is not to scale. We got too many little jaggy thingies in here. Let's see if I can take some of those away. All right, so the area of that. What we do when we find the area of that is we have to make this into something we can take the area of. So I can take the area of this, and then I can take the area of this and add them up. So the area of that is length times width. Well, the length is 3 and the width is 2. So 3 times 2 equals 6. All right, the area of this is 2 times 6. We add them up, and we're good to go. Example 8.2. They give us a rectangle. In fact, let me get a picture of that. There, that's better. And so what's it say? Find the area of the shaded portion of the figure. All angles are right angles. Dimensions are in meters. I don't care what the dimensions are. I just want to know the numbers. So we're interested in only the shaded portion. So let's say that this is a house sitting on top of the yard, and so we're not going to put grass seed there, so we don't care what that is. So let's go ahead and do this. So I get my random marks out of there. All right, so what we're going to do is we're going to find the area of this whole thing and subtract that from it. So 10 times 8, so that gives me 80. That's how big the whole thing is. This little guy here is 2 by 6, so it's 12. So I'm going to take that 12 away from there and get 68 for the shaded part. So not a whole lot to that. All right, let's jump to areas of triangles. Now, some of you already know what the area of a triangle is. The area of a triangle is 1/2 base times height. And that is all-inclusive, doesn't matter what kind of triangle it is, but the thing to remember, and I think we went over this before, this is the base, but the height is the perpendicular or 90-degree line to the highest point of the triangle to the base. It has to be a 90-degree angle. If I have a triangle like this, there's my base, and this is my height. If I have a triangle like this, that's my base. My height is 90 degrees to that. Even though it's outside of the triangle itself, clear over here, I extend my base. I'm not going to use this as part of the area. I'm just using it to find the height here. That's the height of my triangle. Okay, so then it's 1/2 base times height. So if I have a triangle that, come on, can't make it disappear. There we go. Why is the 8 still there? That's dumb. All right, find the area of this right triangle. Dimensions are in feet. So I've got a right triangle. That's 10, that's 8, that's 6, and that's right. So I can choose which one of these is the base. I could choose this to be the base and that to be the height, or that to be the base and that to be the height. It doesn't matter because I'm multiplying 8 times 6 and getting 48. Now, how did I know to multiply 8 times 6, or rather than 8 times 10 or 6 times 10? Right here. If I have two right angle, or if I have one right angle, those two line segments that attach for that right angle are the two that I multiply. So again, if I have a triangle like this, there aren't any right angles there, but if that's the base and I make a right angle there, now I'm taking the length of the base times the length of the height, and then taking half of it. So that's 48 divided by 2 is 24 is going to be the area of that. So here's another one, 8.5. We're trying to find the area. So we don't know how to find the area of that, but if we make this into a triangle, we can do that. So that becomes 6, and this one becomes 4, because when you add them all up, you get 10. So now we take 4 times 6 to get 24. That's the area of the rectangle part. The area of the triangle is going to be, let me get some black here, is going to be base, which is 4, times the height, which is also 4 from this over here. So we get, because this is the 90-degree angle, we take 4 times 4 is 16, take half of it and get 8. So 8 plus 24 is 32. So the area of that whole thing is 32 square yards.